Good morning, student. Today we have a topic recurrent neural networks in machine learning. Recurrent neural network is an important topic in machine learning because it is needed in today's environment when we need to analyze the text, we need to synthesize the text, and we need to go for the machine translation and machine learning in advanced way. So recurrent neural network deals with such kind of the problems. So how we can sort out such kind of problems? So this kind of network deal with as a solution. So recurrent neural network is again important topic in the machine learning. So today we will see this topic into different format and different parts. So now today we have important part, that is a part one, recurrent neural network part one. In short, recurrent neural network is known as RNN. So let's start. Now, what are the important points to be discussed today? So, there are the two important points. One is a feed-forward neural network. In short, it is known as the FFN, and next one is known as the RNN. RNN means a recurrent neural network. Recurrent neural network is an important topic of the today's lecture, in which we need to understand what is meant by the recurrent neural network and what is the purpose of what is the need of this topic or this important point in machine learning. So we will see this important topic. So let's start and continue with the new other points. So first one is feed forward neural network. The first we need to start a neural network basics. Neural network is a computational graph whose nodes are computing units and whose directed aim is transmit numerical information from one node to another node. Each computing unit, which is a neuron, is capable of evaluating a single primitive functions, which is known as the activation function of its input. In fact, the neural network represents a chain of function composition which transform an input to an output vector. So it is shown by the diagram, as you can see to the slide. It is clearly mentioned what is input layer, second one is hidden layer, next one is output layer. So all the information represented by the different vector. So input layer we have the x, and hidden layer we have the h, and output layer we have the y. So the diagram is the diagram is shown by the x is given input as an input layer, and into the hidden layer followed by the some weight, that is w, and respectively h is a hidden layer which is just producing the output, and go for the y, which is the output layer, and followed by the vector v. But if this vector is all about, this vector is represented from the weight. The feed-forward neural network is the most basic and widely used artificial neural network. It consists of a number of layers of computational units that are arranged into a layered configuration. While you can see over here, the G is an activation function for the hidden layer units, while F is the activation function for the output layer units. Unlike all hidden layers in the neural network, the output layer units must commonly have an activation function, linear identify function for the regression problems, while softmax function for classification problem. Now, neural networks using some activation functions. So, as you can see over the slide, we are just mentioning two important activation functions. First one is sigmoid activation function, and next one is the 10H. Both activation functions are also known as the transfer functions. And what are the activation functions are required? So, because of the some reasons, so reasons are non-linear scattering functions we have. Easy to find the derivations, we have to use the activation function. Next one is make stronger weak signals and don't pay too much attention to already strong signals. So these are the basic reasons why which we need to go for the activation functions. The main problems for neural network training is that billions parameter of the model, multi-objective problems, requirement of the high-level parallelism, and requirements to find a wide domain where all minimizing function are close to their minimum. So these are the certain reasons we can't say that it is not easy to train the neural network. But in general, training of the neural network is an error minimization problem. So this diagram is clearly showing that the error minimization problem is the main problem by which we can't easy train any neural network. So to train any neural network is not easy task. Feed-forward neural network can be trained with backpropagation algorithm, propagated gradient descent algorithm, where gradients are propagated backward, leading to very efficient computing of the higher layer weight changes. Backpropagation algorithm consists of two phases. First one is propagation, in which forward propagation of the inputs through the neural network and generation output values. Backward propagation of the output values through the neural network and calculate errors on each layer. Second point is weight update. Calculate gradients and correct weights proportional to the negative gradients of the cost function. Feed-forward neural networks has several limitations due to its architecture. First one is accept a fixed size vector as input, for example, an image. Second one is produces a fixed size vector as output, example, probabilities of different classes. Third one is performs such input-output mapping using a fixed amount of computational step, example, number of layers. These limitations makes it really hard to model time series problems when input and outputs are real valued sequences. Now go for the recurrent neural networks. So far we have seen what is mean by the feed-forward neural network and why we should not go for feed-forward neural network for the process or any kind of the operations where the advanced technology is required. Recurrent neural network basics. Recurrent neural network is a neural network model proposed in the 80s for the modeling time series. The structure of the network is similar to feed-forward neural network with the distinction that it allows a recurrent hidden state whose activation at each time is dependent on that of the previous time, that is a cycle. So as you can see into the diagram, the x0 is the input, x1 is the input layer, and up to the xt. So based on the some time factor, each and every input layer is for giving the some input to the hidden layer, followed by the h0 to up to ht, and producing some output starting from the y0 to yt. So but it has a making a series which is followed by the time. So it is also known as the time series recurrent neural network. So the generalization diagram is given in the left side. So as you can see, it is followed by the U. U is basically a vector which gives the information of the data in which certain information is required to follow up the x2 by x2 by means input layer to the output layer and followed by the completely hidden layer operations. So it is just making an iteration if required. The time recurrence is introduced by a relation for hidden layer activities, that is HT, with its past hidden layer activity, that is HT minus 1. So this dependence is non-linear because of using a logistic function. So as you can see over the slide, HT is equal to logistic function. We have the sigma and enter into the WXT plus UX, so T minus 1. So this is the HT is to be calculated over here, and what is the output, so which is calculated by the function of VHT. So as you can see, already discussed into what is mean by the B, W and U. So U, W, we already seen into the previous slide. So all the things are dependent on the each other. So as you can see over the diagram, what we have HT minus 1, HT and HT. So HT minus 1 is the time in a layer which is on the time, previous time, and the current time is the HT, and the coming time would be the HT plus 1. So with respect to output will be generated, that is YT, and given input will be the XT. So this is the general or simple RNN diagram. The unfolded recurrent neural network can be seen as a deep neural network, except that the neural network followed by the recurrent weights are tied to brain. We can use a modification of a backpropagation algorithm that works on sequences in times. Backpropagation through time, so it is also known as a BPTT. So the full form of the BPTT is backpropagation through time. So first we need to look for first one point is for each training epoch. Uh, this purpose of this point is to start by training on the shorter sequences and then train on progressively longer sequences until the length of maximum sequence will be 1, 2, 3 up to the n minus 1 and up to the n. So this is the meaning of the for each training epoch. And if you talk about the second point, that for each length of the sequence, that is k. So unfold the networks into a normal feed-forward network that has k hidden layers. And last one is preceded with the standard backpropagation algorithm. So this is just idea about the backpropagation through time. Uh, While in principle the recurrent network is a simple and powerful model, in practice it is unfortunately hard to train properly. So what are the problems? In the gradient backpropagation phase, the gradient signal multiplied a large number of times by the weight matrix associated with the recurrent connection. So if the lambda 1 is less than 1, so it means the weights are small. So it has a vanishing gradient problem. While the reverse process of this one is known as the exploding gradient problem. But what are the solutions? The solution can be understood by the simple meaning. So into coming next slide we have the solution. The solution of the problems which is mentioned by the previous slide into the RNN can be understood by the easily method. So first one is exploding gradient problem solution can be identified or can be solved by clipping the norms of the exploratory gradients when it is too large. While the other problem that was the vanishing gradient problems can be sorted by the relax the non-gradient dependency to linear dependency. So for this we have the different techniques. So first one is LSTM, next one is GRU. So all these techniques, LSTM and GRU, we will see into the coming classes or coming video lectures. So far we have seen what is mean by the feed-forward neural network and what is the drawback of the feed-forward neural network and what are the advantage or what is the need of the uh, RNN. So this is just overall idea about RNN and feed-forward neural network. So this is the part one in which we have seen what is meant by the RNN. Rest part or remaining part of this topic we will see into the coming video or the next video. These are the basic references for making this video lecture. So I have taken only the four references which are sufficient to make the concept that the RNN. So taken from the Wikipedia, go for the some part from the Geek course or Geeks and search enterprise enterprise AI.com and so on. So all these references are helpful for making this video lecture. And last one, I have a thank you to all for listening this video. Thank you.